Hi, my name is Kyle, and today my project is on predicting Disneyland ride popularity and designing an optimal Disney day. The project combines theme parks and machine learning to find what's most in demand for the rides, and the end goal, of course, is to build a schedule that maximizes the high-tier attractions. So the motivation behind the project was that Disneyland's really crowded, and the wait times really affect how many rides you can hit. I also really like Disneyland, and I'm super interested in it. So that's kind of why I targeted this project. The questions I wanted to answer were if we can predict ride popularity based off of historic wait time data. And once we predict popularity, can we build a model to classify things from like tiers from 1 to 5? And can we use those predictions to create an optimized ride itinerary? And of course, we want to maximize the number of high tier rides that we can do in a single day. So this is the general predictive task. The goal was to predict the popularity of each tier, 5 being the most popular and 1 being the least popular. The problem formulation is kind of pretty simple. I was going to use 2 features, the average wait time for a given ride throughout the whole day, and then the maximum wait time for that day. And the output would just be a discrete popularity tier from 1 to 5. The models that are going to be used are going to be just the basic baseline model. It's going to be a linear model and a multilinear model. For evaluation, I made a heat map, a confusion matrix that we can see later on. The accuracy was also measured, but ideally it was going to compare my tier list to the estimated tier list that it got from running all of the code. So for the data set, I had to go to a website, and I tried calling the API in order to get the data, but the API only gave the data in 5-minute intervals, and it gave it at the current time. So it didn't give historical data. So I built a web scraper for that I don't have currently here, and it scraped the HTML for the website, and it got every single day from 2015 to 2024, all the way out to 2024, so it ended at 2025. And this data included the ride name, as well as the average wait time, the maximum wait time, and the date that those times were taken from. And then on top of that, I also made another scraper, or another API caller, but I'll discuss that later on. To get like a glimpse of what the data looks like, I have the CSV right here. As you can see, it's the date, the name of the ride, and then the average wait time and the maximum wait time for that day. And I have all the rides. So in the categories, I kind of named everything based off of their tier. And you can see those tier names here. And then I also gave a general description on the meaning. And then over here, I made a graphic to help visualize which rides went where. And later on in the code, I have these all in a dictionary. But if you can see the picture, you might be able to guess where ride it was. So again, this is the label mapping. The input features X are the ride level statistics, so the average wait time, the maximum wait time, and then the output was the popularity tier as described here. So before modeling it, I needed to clean a lot of the data. Some of the data here, as you can see, isn't all from rides. There were some that are from, like, attractions and things like that, like restaurants maybe, or like visiting Mickey Mouse or something like that. So I had to clean out all of that stuff. This is the head of the data, just some basic EDA and some general info. There was a lot of kind of non-null items, which is to be expected. There was 0 missing data, so there should be no null items. And over here, we saw some weird max wait times. Like over here, we saw 900 as a max wait time, which is 15 hours, which is the entire duration that the park is open. And the average wait time seemed to be pretty reasonable, but this was very worrying for me. So I had to look into some outliers. So I ended up just truncating everything at 200 minutes because anything above 200 minutes was like 3+ hours, which is pretty unrealistic for any ride at the Disney theme park. So I just removed all of those, and then I just kind of put some of the outliers. So we can see here there's like 500 minutes, 300 minutes, 900 minutes, which are all very, very unrealistic. I didn't really look into the reason as to why it actually was missing because it didn't really pertain to the project. I just dropped those data points and chose not to use them. So here, this kind of gives like a description of dropping the unrealistic wait time outliers. It just kind of messed with the summary statistics, and it really hampered my EDA process. And removing those rows of data didn't really affect anything too much in the long run because it was just one single data point, which was just 1 day of average and max wait times. So I saved my cleaned copy, and then now I went over to checking for missing data. The missing data was pretty easy to find because there was none at all. And this is because of the fact that the web scraper only scraped data if that ride or that day existed. If there was no data for that day for whatever reason, it just kind of skipped over that day, and it just errored out using some try and accept code. So there was no missing data. So later, as I spoke about earlier, I had to filter out all the data to include only Disneyland rides. I said before, there was restaurants and shops and walkthroughs and character meets, theaters as well. And these were just not considered rides, in my opinion. So I removed all of those, and I basically manually checked to see that they were all rides. The data gave me 67, I believe. Quite a few unique quote-unquote rides, and I narrowed it down to about 33. We also had to rename some of the rides because there's a holiday version, and we didn't want that, so I just renamed them to It's a Small World and Haunted Mansion. And this is the code for it. So as we see, the unique rides, there are 62 different rides. And if you see things like Oga's Cantina, that's a food place. Pixie Hollow, that's like a picture place. So I did that. I renamed the 2 rides first for the holiday versions, and then I had a list to define which rides that I wanted to keep. And then we just, of course, cleaned all of that out, and here's a little bit of a sample and the shape of the data frame that was left over. Then I did some basic visualizations. I made a quick plot with the average wait times. It seems pretty reasonable. Most rides stay within the 0 to, or well, technically 5 to 40 range because 0 wait time doesn't actually exist. Then we see over here we have a very, very small number of over 2-hour waits. These probably come from Rise of the Resistance or rides that just opened and were new for the time period between 2015 and 2025. Most of the rides cluster around 10 to 20 minutes, and this is because Storybrooke has a lot of rides. About, I want to say, 25% of the rides are located in Fantasyland, and they're all like very kiddie rides, so they're like short wait times and quick turnaround times. So that explains the average cluster over here, which makes sense. Then we had a distribution of maximum wait times. Of course, there's a large spike in the beginning for 5-minute wait times, and this is because during the beginning, when the park opens, a lot of wait times online just kind of sit at 5 minutes, just to kind of like start at that range since there's nobody actually in line. And what happens is that if the data wasn't collected for the whole day and it was only collected for certain parts of the day, it might just say 5 minutes for the whole time. But also, it's mostly because a lot of rides just have a wait time that just sits at 5 minutes. For example, on Main Street, there are some cars that go around that can pick you up, and those always show a 5-minute wait time regardless of how many people are in line. So that explains the amount that's over here. And then 45 minutes and 30 minutes is just like a really common time that the ride durations or maximum wait times kind of sit at. It's a really reasonable ceiling that we see pretty commonly on the park. Then I did some wait time aggregation. I computed the mean average wait time and the mean maximum wait time for each of the rides, just so that we can use it later on for classification. This is like just a pretty standard step just to check on what things usually sit at throughout the entire year or throughout all the historical data that I had. And then now I'm starting to get into assigning popularity tier list labels to each of the rides. So this is kind of the bulk of where the project is. So I did a mapping. I wrote out which rides belong to which category, and this kind of just mirrors what was seen in the tier list picture that I had above. And then I just added a column to explain that tier list, just so that it was just nicely tucked into the data frame, so it was easier to work with. And then I have my modeling set up. It was just a basic testing and pretty standard splitting of the data. So I had an 80% train and then 20% test split, so just 80-20, which is pretty standard. And then I used the 2 features to basically find out the assigned tier list. So then I did also a logistic regression model with kind of the same guidelines and things like that. And then the important part was the model accuracy and evaluation. The accuracy kind of popped up a little bit weird, and I think I got 0. And I think that just comes from the fact that it's a relatively easy task to do, I would say, because it is my own rating system and it matches the wait times pretty similarly. So ratings or rides that are higher in the tier list have significantly higher wait times than the ones at the bottom of the tier list. But more importantly, we have the confusion matrix. So our predicted tier was down here, and our true tier was here. The only real worry that I kind of saw was between 4 and 5. If you were to see the wait times for both of them, a lot of tier 4 and tier 5 wait times were pretty similar. It was kind of hard to distinguish just from the wait times. I think even as a human, if you were given wait times from tier 4 and 5, it would be pretty hard to distinguish between which ones were in each tier. So the key observations was that it was pretty good at ranking tier 5. It only struggled when it was given like tier 4 data. Tier 5 was easy to determine because it would be wait times like over 2 hours and things like that. And then the middle tiers were a little bit more difficult to distinguish, mostly because of the fact that they all kind of sat at like a 30-minute wait time, like 15 to 30-minute wait time. So it was kind of the same problem as distinguishing between tier 4 and 5, but it was significantly more challenging because there was just far more rides. Also, in one of the models, no rides were actually predicted in tier 2 or tier 4, which was a little bit odd because it kind of just got lumped in with tier 5 if it was tier 4, and then for tier 2, it would get lumped into tier 1 or tier 3. So the model captures tier 5 really, really well, just because of the fact that their lines are so much longer. I think the biggest problem was that the data set was really small. I think if I were to do this again, I would add Disney California Adventure rides or rides from other theme parks to see if I could get a better understanding of it. But I think overall, the reason why I didn't add that was because I didn't think it would help too much, because the average wait times at Disneyland are going to be very different from the average wait times at Universal. So it would be hard to translate those things. And then I also wanted to add on top of the project that I already did, was to add a ride recommendation and planning system, just to find all the popular rides based off of wait times and then use that to kind of guide how I wanted to spend my day at Disneyland to maximize all of that stuff. So I had a couple of assumptions when making this planning system. Mostly some pretty simple stuff like the park hours, time per ride. I originally wanted to just do 10 minutes per ride, but later on I changed it to be more accurate and use the actual ride times. So I combined the average wait time and the ride duration. I also added walking distances, so I allotted 5 minutes to walk from ride to ride. And the priority tier list was that I should hit all the tier 5 rides first, and then work my way down and kind of fill in all the other gaps with tier 3, 2, and 1. And the final rule was that there would be no repeats unless I had already visited all of those rides. So it kind of guaranteed that we hit tier 5 and tier 4. And over here, I have the duration of all the rides. I did this manually. And then over here, I did a planner data frame just to set everything up. And then I added the ride duration as well as a time block, just to make it easier to handle with the data frame. And here's the bulk of the code. Here's the output. So this was the itinerary. It targeted all the tier 5 rides first, and then it worked its way down, and then eventually it just ran out of time and it didn't do any of the lower tier rides. And you see over here, that's true. And then you also see an end time and a start time with a 5-minute difference. So this is pretty standard. And then I wanted to, on top of this, evaluate the planner against real data that I scraped, or that I use an API call for. Every 15 minutes, I have a script that basically pings the API and asks for the data, and I have all the data accumulated over here. And it just basically had what park it's from, the ride attraction, the wait time, and the timestamp, as well as the day, basically date information. So what I did was I loaded this 15-minute CSV data set into a data frame, and I cleaned it up the standard way, kind of very similar to what I did for the first data frame. I renamed some things, and I eventually compared things like this. since it was the end of the project, I couldn't really like completely get this part down, but the real time wait time would be over here, and then the difference would be over here, and you would see a 0 wait time. That makes sense because it's the very, very beginning of the day and things like that. So it was really cool to be able to see an itinerary that I made and then compare it to the real wait time. But that's the gist of my project. Thanks for listening.